Well, that brings us to shapes already. We can classify bone by shape. And look at the shape. We have bones that are long, we have bones that are short, we have bones that are flat. And then we basically have bones that are irregular. Talk about the sesamoid in a minute. So long bones are longer than wide. Okay. Most of our extremities are like that. And that includes the little fingertips, because the bone, even though it's very small, it's still longer than wide. So it still is a long bone. So don't be fooled by the size of the bone. Then we have short bones, and that just means it's a cube-shaped bone. And mostly we find those in the wrists and in the ankles, the tarsals and the carpals. We'll talk about those names in another chapter coming up. And then the flat bone are the ones, well, they are flat. They're like the skull is a flat bone. The brain's not, hopefully not filled with bone. That would make you very heavy and very hard for the brain to lift. So the flat bones are flat. So brain's easy. Also the breastbone in the front of the chest, that's a flat bone too. And then when you actually look at the ribs, really, the ribs are not round. They are actually flat. But we'll look at those when we look at all the bones. And then the irregular bones are just the ones we can't categorize. They're all weird looking, like the vertebra. They're very weird looking. They have, of course, things sticking out in the back and on the sides, all these processes. And then the hip bone, the pelvis, look at that. It's very difficult to make sense of that bone in terms of a shape. And then that brings us to the sesamoid bones. And the sesamoid bones are not really bones, but they're hard calcium-dense structures that are acting like pulleys inside tendons. And we do that where we need help to have the muscle, when the muscle contracts and it moves the joints and guides it through a motion. If there's no pulley because of the angles of the joints, the muscle movement would be jerky. And so what a pulley helps with, it's like it's a little sort of thing stuck inside the tendon, rounding out a sharp angle, and that will smooth out a motion when we have to move that. Well, the best example is the knee joint. The front knee muscles or the front thigh muscles, if they wouldn't have the knee cap, they wouldn't be rounded, and so they would really have to contract strongly until they can move the knee joint, but then they move it jerkily because the force transfer is just not smooth at that point. So those are pulley helpers. And that brings us to the end of this chapter. That's bone development. We have two types of bone creations, or let's put it this way, bone creation has technical terms, and those are osteogenesis, or the creation of bone, or ossification, the making of bone. And so we have two main types how we can do that. We have one that's called intramembranous, and that means basically bone created in between membranes. And that's one, we have membranes, like in the skull, for example. The flat bones are good examples of that. We have, and actually when a baby's born, you feel the soft spot is membranes. And inside, and then when the baby grows, those membranes fill in with bones and the soft spot disappear for the most part. And so you can visualize it there. So you have two membranes, and inside the membranes, the bone centers start growing and budding out and then filling up with bone. And the other is the endochondral ossification, osteogenesis. And this is a process, endo means inside, condo means cartilage, so this is a process that's inside the cartilage. So for the most of our skeletal system, we have hyaline cartilage models that precede our bone. And so inside that hyaline cartilage, and you know what hyaline cartilage is, it's the ends of bones is still hyaline cartilage. So if you eat meat and have bony joint stuff, you feel that. But so the whole skeleton is the cartilage, and inside those cartilages you have little ossification centers, little parts that then bone starts growing, and you have one of those in the diaphysis, and you got a couple in each of the ends, the epiphyses. And so they make bone, they lay down bone that way. And then between the two we have this ossification plate, this place in the metaphysis that does not close out, and cartilage stays there until the bone reaches its maturity, its length of maturity. And so that gives us a place where